There is a particular kind of sentence that only appears when someone has spent too long looking at reality in a way that most people avoid. A sentence that does not try to comfort you, does not soften anything, and does not ask whether you are ready to hear it. It simply states what seems unavoidable once you accept the underlying logic. And one of those sentences was written by Albert Einstein in a letter that most people read too quickly. The first time they encounter it, he had just lost a friend, not in the casual sense of someone you knew once, but someone who had been there before the equations were clean, before the ideas were famous, someone he had argued with, leaned on, tested thoughts against, the kind of person who quietly shapes your thinking without ever appearing in the final version of it. And when that friend died, Einstein wrote to the family and said something that sounds almost detached until you realize he meant it literally. That his friend had only gone a little ahead in leaving this strange world, and that the difference between past, present, and future is only a stubbornly persistent illusion. Now, if you hear that as philosophy, it feels like a posture, maybe even a defense mechanism. Something you say to make loss feel smaller than it is, but if you read it the way he intended it, it has a very different weight because he was not stepping outside physics at that moment. He was staying inside it as strictly as he knew how, which means the statement is not emotional first, it is structural. It comes from how the world is described, at the level he trusted more than intuition. And this is where things begin to shift in a way that is easy to miss if you are not careful, because your entire life is built on the assumption that time behaves in a very specific way, that it moves, that it carries everything forward, that it creates a sharp boundary between what is still real and what has already slipped away. And you rely on that boundary constantly without thinking about it. You rely on it when you remember something, when you regret something, when you plan something, because all of those depend on the idea that the past is no longer here and the future has not yet arrived. I used to think of time in exactly that way, not because I had examined it closely, but because it never seemed necessary to question it. It felt like the most obvious feature of reality, more obvious than gravity, more obvious than motion, because you can ignore gravity for a moment. You can close your eyes and forget motion. But you cannot escape the feeling that time is moving. It is the background of every experience you have ever had. And because it is always there, it becomes invisible in the worst possible way. You stop noticing that it is an assumption, but then you run into a problem that is difficult to dismiss once you see it clearly, because when you look at the actual equations that describe the physical world, the ones that have survived every experimental test we have thrown at them, they do not behave as if time has a preferred direction. They do not distinguish between forward and backward in the way your experience does. And that creates a gap between what you feel and what the physics allows. And that gap is not small. It sits right under everything you think you know about change. Causality and loss. Einstein understood that gap very well. And what makes that letter unsettling is not the phrasing, it is the consistency. He did not switch to a different language when he was confronted with something personal. He kept the same framework. And in that framework, the idea that something simply disappears from existence becomes harder to justify, because disappearance is not something the equations naturally describe. What they describe instead is structure, relationships, position, a world where events are not erased but located. So when he says that the distinction between past, present, and future is an illusion, he is not saying that nothing matters or that experience is meaningless. He is pointing at a mismatch between how reality behaves at a deep level and how it feels from the inside. And instead of resolving that mismatch with comforting language, he leaves it exposed which is uncomfortable, but also unusually honest, because it forces you to consider the possibility that the way you experience time might not be telling you the whole story. And once that possibility is on the table, it is very difficult to ignore it again. You can test your intuition about time without equations, without theory, without even leaving your kitchen, because there is a pattern that repeats everywhere. Once you start paying attention, things fall apart, they mix, they spread, they blur, and they almost never reverse themselves. And because this happens so consistently, you begin to treat it as a fundamental rule, not just of objects, but of time itself, as if the forward direction is built into reality at the deepest level rather than emerging from something else. Take something simple. No dramatiz, just a drop of ink in water. You've seen it before. The way it expands, curls, dissolves into the surrounding liquid until there is no clear boundary left. And if I ask you to imagine the reverse, not approximately, but exactly, the ink gathering itself back into a tight drop, restoring every microscopic detail of its original state, you immediately feel the resistance, not because you can prove it is impossible, but because your entire experience tells you it does not happen. And from that repeated experience, you build a quiet certainty that time itself must be pushing things in one direction. But here is the part that I find both irritating and fascinating at the same time, because when you actually go to the level where physics is written, the equations do not support that certainty, not in the way you expect. The fundamental laws, whether you are dealing with classical motion, electromagnetic fields, or quantum systems, are almost completely indifferent to the direction of time. You can take the same equations and run them forward or backward, and they continue to make sense. Nothing in the mathematics demands that processes unfold in only one temporal direction, which means the asymmetry you see everywhere is not coming from the core rules themselves. That leaves you in an awkward position, because now you have two things that both seem undeniable but refuse to agree with each other. On one side, your direct experience of a world that clearly evolves in a single direction. And on the other side, a set of equations that refuse to privilege that direction. And if you stay with that tension long enough, instead of resolving it too quickly, you begin to notice that the difference might not be in time itself, but in the kind of systems you are looking at. This is where entropy enters, not as a philosophical idea, but as a statistical one. And I think it helps to be very precise here, because entropy is often described loosely as disorder. But what it really measures is the number of microscopic configurations that correspond to the same macroscopic appearance. And once you understand that, a lot of everyday phenomena start to look less mysterious, because there are vastly more ways for a system to be spread out, mixed, and disorganized than there are for it to be neatly arranged, and that imbalance drives the behavior you observe. So when the ink spreads through the water, it is not obeying a rule that says you must move forward in time. It is simply moving toward states that are overwhelmingly more probable given the number of ways the molecules can arrange themselves. And the reverse process, while not forbidden by the underlying laws, is so statistically unlikely that you effectively never see it. And from inside a world where you only ever witness the probable direction, it becomes very easy to mistake probability for necessity. Now bring yourself into this picture, because you are not watching entropy from the outside. You are a system shaped by it. Your brain records information by creating physical changes, traces, left behind as events unfold. And those traces always point in one direction, toward what has already happened, because that is where the information has been deposited, while the future contains no such traces, no physical record waiting to be accessed. And so your memory becomes inherently one-sided, reinforcing the sense that the past is fixed and the future is open. I used to find it slightly unsettling that something as fundamental as the direction of time could depend on something as mundane as probability distributions, because it suggests that what feels like a deep feature of reality might actually be an emergent effect of large numbers, of systems with many components behaving in statistically predictable ways. And that realization doesn't immediately change how time feels to you. You still experience it as flowing forward. You still watch things decay and not reassemble, but it quietly shifts the explanation from "this is how time works" to something more specific, which is that this is how systems like you behave inside a universe whose basic rules do not insist on a preferred direction at all. Most people don't question time because it feels consistent, not just personally but collectively, as if there is a shared rhythm running underneath everything, a universal ticking that keeps all events aligned. And if you and I were to meet and compare our experiences, we would assume without hesitation that we are moving through the same now, that whatever is happening for you and whatever is happening for me belong to a single, synchronized slice of reality. And it is precisely this assumption that begins to fail the moment you take relativity seriously. What makes this failure so unsettling is not that time behaves strangely at extreme conditions, but that it behaves differently in ways that are measurable, repeatable, and already built into the systems you rely on. Because relativity does not introduce a minor correction to an otherwise stable picture. It removes the idea of a universal clock entirely and replaces it with something far more flexible, where time depends on how you move and where you are located in a gravitational field. There is a classic experiment that captures this in a way that is almost too simple to be convincing. Atomic clocks placed on aircraft, flown around the Earth, and then compared to identical clocks that remained on the ground. And when the clocks were brought back together, they did not agree, not by a large amount, but by exactly the amount predicted by relativity. The moving clocks had experienced less time than the stationary ones, not because something interfered with their mechanism, but because the passage of time itself had been different along their trajectory. I remember the first time I tried to take that seriously, instead of treating it as an interesting anomaly, because it forces you to let go of a very deep assumption, the idea that time is something absolute, something that flows independently of what you do, and replace it with the realization that time is part of the physical structure you move through, that it can stretch, compress, and vary depending on your motion. And that variation is not an illusion, not a measurement artifact, but a property of reality itself. And motion is only part of the story because gravity introduces its own distortion. A clock closer to a massive object runs more slowly than one farther away, which means that time itself is affected by the curvature of space-time. And I have always found it useful to think about this in ordinary terms, not because the differences are noticeable, but because they are real. A clock on the ground floor of a building ticks at a slightly different rate than one on the roof. Not enough to matter for daily life, but enough to remind you that time is not uniform, even across small distances. Now take both of these effects together, velocity and gravity, and you begin to see a pattern that cannot be explained by treating time as a background parameter, because what you are observing is not just variation in clocks, but variation in the structure of time itself. And this is where the idea of space-time becomes unavoidable. The recognition that space and time are not separate entities, but parts of a single four-dimensional framework where every event is defined not just by where it happens, but when it happens, and those two aspects are inseparable. There is a system operating above your head right now that depends on this being true in a very practical sense. GPS satellites orbiting the Earth at high speeds and in weaker gravitational fields, their clocks run at rates that differ from those on the ground. And if those differences were ignored, the positioning data you receive would drift rapidly, accumulating errors that would make navigation unreliable within a short time, which means that every time you check your location, you are relying on corrections derived from relativity, not as a theoretical curiosity, but as an operational necessity. So at this point, the picture has changed in a way that is difficult to reverse, because if time can pass at different rates for different observers, if there is no single clock that defines a universal present, then the idea that all events are being carried forward together by a single flow becomes hard to maintain, and instead you are left with a structure in which different paths through space-time correspond to different experiences of time, different sequences of events, and different definitions of what counts as simultaneous. And once you accept that, even reluctantly, you begin to see that time cannot be treated as something that simply moves everything along, because movement itself depends on the path taken through space-time, and what you call the present is no longer a universal feature of the world, but something tied to your specific trajectory, your motion, your position. And that shift, subtle as it may seem, removes the last support for the idea that time is a single flowing entity shared by all observers. If you take seriously the idea that there is no universal now, that different observers do not agree on which events are happening at the same time, then something very specific starts to break. Not gradually, but cleanly, and that is the idea that the universe is unfolding moment by moment in a single shared present. Because for that picture to work, you would need a global slice of reality that everyone agrees is what exists right now. And relativity simply does not give you that slice. So you are left with a choice, and it is not a comfortable one. You can either hold on to the intuition that only the present is real and accept that physics cannot consistently define what that present is, or you can take the equations at face value and accept a picture that feels much stranger at first, which is that all events, past, present, and future, exist within a single four-dimensional structure, not being created and destroyed, but simply located at different coordinates. I resisted that second option for a long time, not because it was hard to understand, but because it removed something I had always relied on without noticing it, the sense that reality is being generated as time passes, that there is a kind of ongoing production of existence, and replacing that with a static structure felt like flattening something that should be alive. But the more you try to preserve the idea of a moving present, the more inconsistencies you run into, and at some point it becomes simpler, not easier emotionally, but cleaner logically, to accept that the universe might not be happening in the way you think. In this picture, sometimes called the block universe, space-time is treated as a complete entity, a four-dimensional manifold, where every event has its place, and your life, instead of being a sequence of moments that come into existence and then disappear, becomes a continuous path through that structure, a line extending from the point you call your birth to the point you call your death. And every point along that line is equally part of the structure, not privileged, because you happen to be experiencing it, not diminished. Because you are not, there is a way to make this feel less abstract if you shift how you think about space first, because you already accept without difficulty that places you have left behind still exist. The house you grew up in does not vanish when you move away. The street you once walked down is still there, even if you never return to it, and the fact that you cannot access it right now does not lead you to conclude that it has been erased. You understand it as a limitation of your position, not a statement about its existence. What relativity does is extend that same logic to time. It says that moments you have moved past are not destroyed. They are simply no longer on the part of the path you are currently traversing. And that shift is small in wording but large in consequence, because it removes the idea that the past has been eliminated and replaces it with the idea that it remains exactly where it was. Fixed in the structure of space-time, I remember trying to find a way around this, some mechanism that would allow events to genuinely disappear. But every attempt required adding something extra to the theory, some additional rule about which slice of space-time is real and which is not. And those rules always felt artificial, as if they were trying to preserve intuition rather than follow from the mathematics. And that is usually a sign that you are forcing the picture instead of discovering it. So if you follow the cleaner path, you end up with a universe that does not update itself moment by moment, but exists as a complete structure where all events are laid out. And your sense of time passing comes not from the structure changing, but from your experience moving along your path within it, illuminating one part after another, creating the impression of flow without requiring the underlying reality to flow at all. This does not immediately make the world feel different. You still experience change. You still remember and anticipate, but it shifts what those experiences correspond to. Because instead of reflecting a universe that is constantly discarding its past, they reflect a process that is selecting different regions of an already existing structure. And once you see that clearly, the idea that moments truly vanish becomes harder to defend. Not because it is emotionally inconvenient, but because the framework you are using to describe reality no longer needs that assumption. Grief does not arrive as an idea. It arrives as a disruption, something that quietly breaks the continuity of your day in ways that are almost trivial on the surface but impossible to ignore once you notice them. The instinct to share something that no longer has a destination, the brief illusion that a message could still be sent, the way a familiar space feels structurally unchanged and yet functionally incomplete. And what makes it so difficult is not just that someone is absent, but that the world continues to produce new moments without them, as if the system you are part of has shifted while refusing to acknowledge the shift in any explicit way. If you stay entirely within that experience, it feels like subtraction, like something has been removed from reality itself. And that interpretation is deeply compelling because it matches the way your mind organizes the world. But once you place that experience inside the framework we have been building, something more precise begins to emerge. Not more comforting, but more exact. Because in a space-time structure where events do not vanish but remain at their coordinates, the moments that included that person are still there, unchanged, complete, not as memories, but as parts of the geometry itself. What has changed is your position relative to those moments. And this is where entropy becomes relevant again. Not as an abstract principle, but as a process that continuously separates states from one another. Because entropy ensures that systems evolve toward configurations where information is more dispersed, less accessible, and harder to reconstruct, and your brain, being part of that system, does not preserve the past in a stable, fixed form. It preserves traces, physical imprints that degrade, shift, and reorganize over time. I have always found memory to be less reliable than it feels in the moment. Not in the sense that it is useless, But in the sense that it is reconstructive rather than archival, you do not retrieve a perfect copy of a past event. You rebuild it from the available traces, and those traces have already been shaped by previous recollections, by emotional context, by what you have forgotten, as much as by what you retain. So what you experience as remembering is already a transformed version of what once occurred. And that transformation continues as entropy works on the physical substrate of memory itself. Now combine that with the fact that no new shared moments are being added, no new interactions are occurring, no new traces involving that person are being formed. And you begin to see why the feeling of loss intensifies over time rather than stabilizing. Because the system is still evolving, still generating new configurations, but the set of states that include that person is fixed, no longer extending forward. And the distance between your current state and those earlier configurations increases as entropy carries you into regions of the state, space that no longer overlap with them. From inside that process, the interpretation of "they are gone" feels unavoidable. Because your access is diminishing, your ability to reconstruct those moments is weakening, and your present no longer contains direct interaction with that person. But the physics describes something slightly different. It does not say those moments have ceased to exist. It says they are located at coordinates that your current trajectory no longer intersects. And the distinction between non-existence and inaccessibility becomes important. Even if it does not immediately change how the loss feels, there is also something worth noticing about the traces that remain, the photographs, the recordings, the objects that still carry patterns shaped by that person's presence, because these are not symbolic in a loose sense. They are physical residues, configurations of matter that encode past interactions, and they persist because entropy has not yet erased them completely. They are temporary anchors that allow you to reconstruct fragments of what has already been fixed in space-time. And over time, they too will degrade. Not abruptly, but gradually, as all ordered structures do. So what you are left with is a situation that is less clean than the simple story of disappearance. Because nothing has been deleted from the structure, but everything about your relationship to those moments is changing. Access is narrowing. Reconstruction is becoming less precise. And the forward movement of entropy ensures that the gap between your present and those past coordinates continues to widen. And that widening is experienced not as distance, but as absence, because your mind has no direct way to perceive it. Otherwise, at this point, it would be very tempting to treat everything we've said so far as settled, to take the block universe picture and carry it all the way through as if it were the final answer. But that would be a mistake. Not because the idea is weak, but because physics, when it is working properly, is careful about what it claims, and even more careful about what it cannot yet resolve. And time turns out to be one of those places where the structure is clear, but the interpretation is not completely closed. There are different ways physicists try to make sense of what relativity is telling us, and they do not all agree on how far to push the implications. One view takes the block universe at face value and says that past, present, and future all exist equally within a four-dimensional structure, that the entire history of the universe is laid out complete, and what you experience as the present is simply your position along a path through that structure. Another view tries to preserve a sense of becoming by suggesting that the past is fixed, but the future is not yet part of the structure, that reality is growing. adding new events at the edge of what exists, while a more intuitive but harder to reconcile position insists that only the present is real and that both past and future are abstractions rather than physical regions. I've gone back and forth between these ideas more than once, not because I enjoy indecision, but because each of them captures something that feels right at one level and incomplete at another. The block universe aligns cleanly with the mathematics of relativity. It does not require extra assumptions about which moment is special, but it comes with a cost. It removes the intuitive sense that the future is open and that the present is being created, while the growing block keeps part of that intuition but introduces a boundary that physics itself does not clearly define. And presentism, while emotionally appealing, struggles to accommodate the fact that different observers cannot agree on what the present is. So there is no single interpretation that resolves everything neatly, and that is not a failure. It is a sign that we are at the edge of what the current framework can tell us, because the equations describe the relationships between events, their positions in space-time, the way they influence each other through fields and forces, but they do not describe what it is like to experience those events from the inside. And that gap becomes especially noticeable when you try to connect the structure of time with the experience of being in time. This is where the discussion runs into a boundary that physics has not yet crossed: the question of whether the existence of a moment in space-time implies anything about the presence of experience at that moment, because the block universe can tell you that a past version of you exists at a certain coordinate, with a certain brain state carrying out certain processes, but it cannot tell you whether that version of you is still having that experience in any meaningful sense, or whether experience is something that only occurs at the moving edge of entropy, where systems are actively evolving and interacting. I have never found a completely satisfying answer to that. And I don't think anyone else has either, because it mixes two problems that are difficult enough on their own: the nature of time and the nature of consciousness, and expecting a clean resolution from their combination is probably asking too much from our current understanding. So the honest position is to stop where the evidence stops, even if that leaves something important unresolved. What the physics does give you, and this part is not ambiguous, is a description of a universe where the events that make up your life are not erased as time passes. They are part of a structure that does not discard what it contains, where the past remains fixed. Whether or not you can access it, whether or not you can reconstruct it, whether or not it feels close to you. And that is a narrower claim than people often want, but it is also a more precise one. Whether that precision feels meaningful is a different question, because it depends on what you think matters more. The persistence of the pattern or the continuity of the experience, and physics, at least for now, only speaks clearly about the pattern, leaving the rest open, not as a gap to be filled with convenient answers, but as a reminder that understanding the structure of reality does not automatically resolve how it should feel to live inside it.